Hello, everyone. Thank you for being here last session. I know it is hard to stay here, but well, let's try to do it at least a bit funny. So today's session is about a research that we did at VirusTotal. I am security engineer at VirusTotal. My name is Jose Luis, also known as Joselillo, coming from Spain. As I said, we are going to see research that we did related to link files and also ISO images, where we saw some kind of pattern in our telemetry. So this is the agenda for today. First of all, I'm going to explain why I'm here talking about this. Then we are going to see the final scope that we got for the research, and then we are going to see some examples related to the findings that we had through our platform. And finally, we are going to see also some examples that we found using the same, let's say, TTPs, but in this case, instead of using LNK files, using ISO images, okay? In the last point, we have uploaded to our GitHub some Java lifetime rules, just in case you want to use them, because we believe that the findings that we discovered in this case related to some threat actors that are using this in the wild could be interesting to use it in your infrastructure as well to identify or to monitor possible similar behaviors. So why this research? As I said, we have observed that in recent months, many advanced and cybercrime groups showed to their victims some PDF, legitimate PDF, in fact, just a decoy during their operations, while in the background, they are doing some stuff. They are executing bad things from some link files that were distributed initially to the victims, okay? So as we saw that it was a trend in our platform, I mean, there was some kind of files that were uploaded in the last month. We wanted to study these trends and show what we found in our telemetry, just to share with the community, as we are not a CTI vendor and we are not doing CTI reports. Our goal is to share with the community some findings and ways to do hunting using VirusTotal or GTI in general. So I wanted to highlight that this is not a new technique or procedure, but it's a trend that we found in our platform. So this is the telemetry that we have using this kind of behavior. So as you can see, in the last month, from probably October 2023, there was a peak of LNK files using this specific behavior, which is drop PDF files during the execution, just to open the PDF as a decoy to deceive the victim, and in the background, execute some kind of malicious code, usually PowerShell or bat files. So, and this is not something that we observed. This is something that also other vendors are seeing in the wild, used by some threat actors. So in this case, for example, this is a report made by Lab 52 in July 2023. They were talking about some threat actor, which is having some similar TTPs related to APT29, where they discovered that this specific threat actor was targeting Chinese users. And as you can see in this case, the RAR file, which was the initial payload in this campaign, contains a link file, which was executing a bad file and then opening and dropping the PDF, which was a decoy, just to show the document to the victim, while in the background there was other activity in the background. Similar stuff, in this case, a report made by G Data Software. In this case was Turla, a campaign made by Turla. In this case, what we have is also a link file. Instead of using a bad file, they were executing PowerShell, and the PowerShell was dropping the decoy PDF. And just another example, just to show you that this is not something that we discovered. Obviously, it's something that is widely used by some threat actors. Checkpoint also reported an example of this behavior, this TTP, where the initial payload was a zip file The link file runs, in this case, also PowerShell, and then the PowerShell drops and opens the PDF. There are, after that execution, some other stuff that is happening in the background in the system, but it was interesting for us because at the end, it's like a kind of trend that we found in our telemetry, trying to figure out why they were using this and how we can create some kind of detections or hunting rules or hunting queries to identify this behavior proactively in our platform or maybe in other platforms, internal platforms, for example, like EDRs or others. So in addition to the link files, as we saw previously, we also observed that the ISO images and PEEXE binaries were using this specific behavior sometimes in other campaigns made by other different threat actors, mainly the ISO images, which is where we discovered that besides dropping and opening the PDF file, they were using also some kind of DLL sideloading techniques to load the final payload in the system. We are going to see later some example of real samples that we have discovered related to some APTs in this case. So, well, the scope. Initially, I started taking a look of our internal data in VirusTotal to identify how many files we have in relation to the file types that we were involved in this investigation. So as you can see, there are so many files, just having more than 5 positives in this case, related to the file types that I was interested in this case. So this was an easy query, I would say, internally, just to see the numbers related to the file types that we have internally in VirusTotal. But for the purpose of the investigation, we had to add some kind of filters just to get files that were that were dropping the PDF files and that were opening the PDF files in our sandboxes. And this is interesting because, for example, in VirusTotal, we have as a default application to open the PDF, Adobe Acrobat Reader. So if you know that, and you are investigating some investigation in VirusTotal based on samples that you discovered in your infrastructure, for example, if you know that, you can create live-hand rules and queries in VirusTotal using the software that we have installed by default in our sandboxes to do hunting. So in this case, because we are going to do the hunting internally in VirusTotal, for us, it's interesting that the processes contains the Acrobat Reader process name and also the .pdf extension in the same command line, which means that Acrobat Reader was used to open a PDF during the runtime in our sandboxes, okay? So with that, these were finally the numbers that we use for this investigation. All those files that are related to each of the file types, I have created different collections in VirusTotal. At the end of the presentation, you have the links, just in case you want to take a look of those files and do your own investigation or whatever. Well, link files. First of all, I wanted to just do a brief introduction about the link structures. Link structures, you have the internal, the documentation of the link structure made by the Microsoft team in that specific link. There are some structures that are interesting and important for the link files. As you can see, these are the main ones, the structures that are made the LNK files with different information that is stored by default when it is created and so on. But in this case, for us, which is interesting, is the structure called string data, because it's the one that is going to store specific information that we are going to use for do threat hunting through our platform. So for example, this is the information related to string data in the documentation of Microsoft. And we have here the command line arguments field, which is a field that we are going to use for do threat hunting, since they are using the link files to create and to open new processes during the runtime execution. And yeah, that information about the structures, we are mapping that in VirusTotal. You have this, the same information that you can see using other external tools to extract the structures and metadata related to the link files. You have that information in VirusTotal, and you can use this information to do hunting, pivoting, and other stuff. So you can click on whatever you want, and then you are going to create a new query in VirusTotal just to see if there are other files sharing the same information and having some similar behaviors. And obviously, this can be used also in the Jara lifetime rules to create new detections and proactively identify new files that can contain some specific kind of string in some of the fields that we are mapping internally in VirusTotal, okay? So now, if we take a high-level representation of the common behaviors that we observed during the investigation that we did, these are the files that were involved of the execution chain that was used in the most of the campaigns that we investigated during the investigation. Some of the questions that I asked myself in order to create good detections and hunting queries and so on were who is in charge of dropping the PDF file? The other one was who is in charge of opening the PDF file? Because answering those questions, I could create some kind of lifetime rules with probably low level of false positives related to new possible identifications. But for that, we have to understand a little bit how it works, how works the campaigns that we were tracking. So, for example, in some of the campaigns that we initially started investigating, there were some payloads, the initial payloads, binary files mainly, that were dropping the PDF during the execution. So, were some kind of small set of files, but not all of them. The other case that we asked ourselves were, okay, so can the link files drop the PDF files during the execution? That is something that cannot happen because the link files are just only a file that is executed, but is executing the argument that is set in the command line argument field into the string data structure within the link file. So if you, and we are going to see an example in the next slides, the link files can create or can execute something in the system. I mean, it's just a file that is not going to do something because it's just executing, it's responsible to execute the next stage, okay? So in this case, for example, the link file is not going to drop the PDF, but if the link file is executing a PowerShell script or BAT file, which is in charge of dropping the PDF, is the one that we are going to see in our telemetry, creating the file, finally. And now the next question was, who is in charge of opening the PDF? So it can be led by the initial payload as well, for example, the .exe or the DLL that was executed or whatever. That specific file can sometimes use to open the PDF, and usually the PDF is going to be opened by the default application that we have in our system to open the PDF. It can be a Acrobat Reader, it can be Google Chrome, for example, it can be other kind of software used to open just the PDF. And the other scenario that we observed in the different campaigns that we were investigating was that mainly almost all of the files and the campaigns that we saw, the processes that were in charge of opening the PDF were the BAT files, the PowerShells, and the Visual Basic scripts, okay? So having that into account, we are going to see some examples. Sorry. Okay, so we have been exploring different scenarios where we saw who was in charge of creating and executing the PDF file dropped during these campaigns. Now, in order to create good detection and track these campaigns, we need to understand how our sandboxes works and where we want to detect this, okay? The further you are to the left, you looked at the information, the more details you will have of the entire campaign. I mean, in VirusTotal, if you have a zip file, let's suppose a campaign where a threat actor uses a zip file, and then the zip file contains a link file, the link file drops a bad file, and the bad file drops a PDF, for example. All those 4 files are going to have their own report made by the sandbox in VirusTotal/GTI. If you go to each of those reports, you are going to see different information at the end. I mean, if you, for example, take a look of the zip file report in VirusTotal, you are going to see the entire campaign, the entire infection chain, and that is really good because you are going to see how was happening everything, and you can create some kind of good hand rules to identify in the future similar TTP, similar behaviors that can be created based on sandbox artifacts that we already have in our sandboxes. So the next question that I asked myself was, okay, so what I want to detect? I mean, in which point of this infection chain I want to detect the activity? Do I want to detect the PDF file for itself? I mean, do I want to detect only, for example, there was a PDF file, a legitimate PDF file uploaded to our platform having as a parent, for example, a bad file? Or do I want to detect the LNK file when it is uploaded and executing some kind of PowerShell? So those are some of the questions that you have to ask yourself in order to create the detections internally. And also, you have to do the same if you want to create some kind of detection internally. I mean, because it's not the same. Create rules for VirusTotal, for example, as giving you the same example as we saw before, the Acrobat Reader process, because maybe you internally you don't have Acrobat Reader installed and you don't want to detect, or it's not necessarily to detect that kind of behavior internally. So you have to change the artifacts, you have to change the logic of the detection when you are creating Jara rules in VirusTotal and when you are creating the internal detection in your platform, like EDRs, XDR, SIEMs. So this is related to what I said before. I mean, who was in charge of dropping the PDF? Okay, so if we go to the VirusTotal report, there is an option where you can download the Sysmon events related to the execution. So in this case, if we take a look of who was in charge of dropping the PDF in the campaign, in this specific campaign, which is a campaign related to a patchwork APT, a campaign that was made 2 months ago, I think, against Chinese users. The process who was creating the PDF, taking a look for the 11 event of Sysmon, which is create file. The file was created by PowerShell in this case, okay? And this is the path, especially where it was created. And if we take a look and we try to identify who is in charge of opening the PDF, we are going to see that the person who was opening the PDF was Acrobat Reader. The parent of Acrobat Reader was, in this case, PowerShell, was on the link file, in this case, because the link file is only executing a huge command line related to PowerShell in order to do some stuff, not only open the PDF, but also download other artifacts and do some other stuff in the system that we are going to see later. So in this case, PowerShell using subs, which is an alias of start process, was the one who was executing by default Acrobat Reader, because it's the default application that we have in the sandbox for opening the PDF, the one who did that in the sandbox. So how can make it actionable to track similar campaigns? So for example, what we want to detect in this case is just an example of suspected scenario that we want to identify is I want to detect link files that executed PowerShell, dropping and executing PDF files as well. So first of all, what we want to detect is the link files. So with the metadata tags modifier in the Jara lifetime rules, we can achieve that. Following that, what we want to detect are PowerShell executions in the sandboxes. And as you can see here, we have 3 different modifiers, just specifying exactly the same, the PowerShell string. And the reason because I am doing that is because sandboxes are not perfect, and sometimes there are some mistakes by the sandbox, or maybe because the way that we are parsing the information to store it into the platform. And if you are looking just for processes created that contains PowerShell, maybe you are losing information that only was seen in the command execution field into the sandbox. So it's just a recommendation I use to create the lifetime rules when I want to detect some kind of process executed. I used to use these 3 different modifiers to identify the same. The next that we want to detect in this case is the PDF created in the system. So as we saw before, in this case I am using 2 different modifiers. The first one is the files written in the system, which in this case I am interested to identify .pdf as an extension of the file created into the system during the execution. And the other modifier is the file drop, which is a different modifier. And in this case, I am using also the extension, but also this is something that we have for file drop, but not for the files written. We are storing in the structure of the lifetime rules the process which is dropping some specific file. So in Jara lifetime rules, if you want to create some kind of Jara rule where some file was dropped, you can also specify the process who was in charge of dropping that specific file, okay? And finally, what we want to detect in this case also is that the PDF is not only dropped, but also executed during the runtime. So as we said before, Acrobat Reader is our process that we want to look for, and also the PDF extension. So with that rule, you are going to be able to detect similar behaviors about the trend that we observed over the last month in VirusTotal. But there is also another way that you can do that, and it's with the EBTX for itself. In VirusTotal, when there is a file which is executed in our sandboxes, and there are some Sigma rules that were mapping the behaviors related to the sandbox, to the malware execution, we are mapping those Sysmon events in the structure of the file to create lifetime rules. In other words, see, if for example, we had some kind of file mapping some Sigma rule in our infrastructure, that log that you are seeing here related to Sysmon is the raw event that was identifying the specific Sigma rule during the execution. So if you want to add more information about how it works and how you can create these kind of Sigma rules, you can take a look at this blog post that we made last year. So some information that we saw interesting during the investigation. For example, this is a chart of the target file.name, which are the processes that are going to be executed by the link files by default, okay, when it were created. The most processes that we observed during this research were PowerShell at CND, obviously. It's not something that, obviously, I mean, it's something that we are seeing a lot in multiple APTs and also cybercrime groups. But for us, which was interesting in this case, was that there were some other processes that were using during the link files execution. And there are a lot of, for example, for this specific process, for files.exe, which is a legitimate process of Microsoft Windows. If you take a look in VirusTotal of link files having that specific process in the target file .name in the metadata, you are going to see a lot of malware using that process just to execute the final payload, which is probably some kind of PowerShell or bat file in the background. The purpose of for files is just to identify some file, and in the way that they are using the for file is just to see if a specific file exists in the system, and if the file exists in the system, it's going to execute the rest of the code, which is a PowerShell or some kind of CMD command or whatever. The way that we're executing the link files, obviously, were minimized. I mean, nothing showed to the victim. They are not going to show anything, some kind of terminal. Nothing is going to be, let's say, in the screen of the victim finally. And when the link files are executed, usually there are other files that are dropped during the execution. So the most files that we observed, the most file types that we observed were binaries mainly. .exe and DLLs were the main ones. But also we saw some other files that were dropped during the link files to continue the final execution, the final chain, and achieve whatever purpose had the threat actor. And also from all the drop files by the link files, we wanted to take a look of the, let's say, the main families that we could identify through our platform that were related to some kind of family at the end. So, I mean, when the link files are executed and are dropping some .exe or DLL or whatever, those .exe or DLS are the families that are dropping into the system. So these are some of the families that we observe in the campaigns that we were studying. You can, for example, use the malware config followed by the family name in VirusTotal to identify families or samples related to some kind of family. And in this case, which was interesting for me, at least, was that the second one was Shellsting, which is also known as Bumblebee. Okay, I tried to take a look of, indeed, a bit more information about the Bumblebee, why it was widely used in this kind of behaviors that we were investigating internally in the link files with the PDF, I mean. So I started taking a look of past campaigns related to Bumblebee. This is an example of Proofpoint report that they reported that in February of this year, they identified a new campaign related to Bumblebee after 4 months of no activity of the threat actors behind this specific piece of malware. And then, as many of you probably know, there was an operation by the FBI called Operation Endgame some months ago in May, where they basically they were doing some kind of operation against the Bumblebee and other malware families just to disrupt their operations at the end. So with that, what I wanted to take a look was, okay, in BT, let's say what we had related to these campaigns of link file with PDF as a decoy to deceive the victim, what we had. So for example, as you can see here, the last month, in July mainly, was when more or less the FBI reported and disrupted the operation related to Bumblebee. Then you can see in the orange square the report, more or less the time when the Proofpoint threat research team did the report, and they said that in February they saw a peak of activity related to Bumblebee, which is probably this peak that we are seeing here. But we had in VirusTotal was that the 3 or 4 months before, more or less from October, if I'm not mistaken, we had a peak of different Bumblebee samples or dropped, executed by link files into our platform. So probably there was some kind of operation during those months, and the files were available in VirusTotal, and we wanted to take a look only to see why, I don't know, maybe there is something, some builder or something that the Bumblebee samples were created with some kind of link builder or something like that. I don't know. So the other thing that we wanted to share was the matching IDs that we identified related to some threat actors that we discovered during the investigation. So in VirusTotal, if you use, for example, the metadata modifier followed by some of these matching IDs, you are going to get samples related to those threat actors in our platform. Those matching IDs are, if I'm not mistaken, the NetBIOS name of the system where the link file was created. So these are some of the matching IDs that we discovered, and we are following and tracking related to these specific APTs. And we are going to see an example in the next slide about patchwork in this case. And the other thing that we wanted to take a look about the link files were the Sigma rules. Most of the Sigma rules detecting these behaviors that we are seeing of PDF file drop and executed were targeting behaviors related to command line interpreters, mainly PowerShell and also CMD. So with these specific Sigma rules, you can detect also, and adding some kind of others modifiers in VirusTotal, you probably can identify proactively new files related to this specific trend that we observed. We were talking about the drop files, but just to give you some insight about the parent files that were executing the link files or embedding the link files, these were the main execution parent that we observed. So what we can see in this specific chart is that the link files were initially distributed using zip files to the victims. We also had .exe files, we had ISO, and sometimes, as you can see in the last point, we had some link files that were executed to drop another link file into the system. And some of the command line arguments that we were observing in multiple cases in the investigation were some of these. I mean, these are how the command line started in the link file, in the command line argument. Most of the link files started like for execute command, for example, the cmd.exe binary like this, and the PowerShell one were starting with these specific commands. But some of the interesting comments that we also saw during the investigation were, well, the threat actors were trying to do some kind of obfuscation or whatever to difficult the analysis of the analysis. So as you can see, there are, for CMD, we have this one, and for PowerShell, some of the most interesting that we identified that you can use for create lifetime rules based on the metadata that we have in VirusTotal for the link files. So let's see an example. Patchwork APT, okay? This is an Indian cyber espionage group that has been seen targeting industries like military, diplomatic, government agencies, and mainly to China, Pakistan, or Sri Lanka. So the campaign that we were trying to figure out how it works and why they were using this kind of behavior started with a zip file, which contains the link file inside of the zip file. So once the user unzip the zip file and execute the LNK, it starts the PowerShell.exe process, and then it downloads two different files from the same domain but in different URLs. Using the alias, this specific alias for PowerShell to download files, invoke web request, they downloaded the PDF file and also a .exe file called sand.exe. After that, what they did was opening the PDF file to the victim. So in that moment, the victim is seeing in their screen the PDF file with the content of that specific file, which was a content related to a conference in China, if I'm not mistaken, which is a legitimate file. It's not doing anything in the system. But behind, in this case, the threat actor is also copying the PDF file to the desktop, if I'm not mistaken. Was also it's not running the slider. Okay, now perfect. So then the PowerShell, what was trying to do was rename the sand.exe to update.exe in the system, and also executing schedule.exe to create a persistent for the binary that was downloaded during the intrusion. And finally, is trying to remove some kind of files into the system with the specific pattern that we are seeing in the screen. And the update.exe was executed to do communication with external URLs. So this is just an example of campaign that we saw. It's not the only one. We saw multiple campaigns for also other threat actors using this specific behavior where they are executing PowerShell, and with PowerShell are dropping the PDF, opening, and then doing other stuff, okay? And yeah, for the ISO image, we have some similar behaviors, I would say. In this case, the main operations that we observed and threat actors using this specific behavior, they were using DLL side loading to execute the final payload embedded into the DLL with the malicious code, and using some kind of a legitimate.exe file, which was in charge of loading the DLL, and the DLL was in charge of opening and dropping the PDF, okay? So the main bundle files that we observed into the ISO images were these ones, okay? So mainly, most of the ISO that we saw were embedded in some kind of PDF just to deceive the victim. And then, obviously, we had the .exe, DLLs, and other kind of file types during the operation. Mustang Panda is one of the main threat actors that we observed doing this specific behavior, which was interesting for us. And into the ISO images that we had during the investigation, the main malware families that we identified were these ones, okay? So beacons, some kind of beacons were the most used in this case, but we have also other rats that we had in the link files, like the Rancor, async rat, or Agent Taylor, for example, for info stealing or other stuff. And this is another example related to ISO. Dark thing, okay, this specific group. This is the file that we have in our platform, which the ISO contains the DLL, the malicious DLL. It contains also a legitimate.exe, which in this case is the legitimate binary of Microsoft Office, which was in charge of loading this DLL. And also, the cool thing here, I mean, the behavior that was interesting for us in order to create some detection and so on, were that they were also using PDF and the Word document with the same content, just to deceive the victim, while the malicious code of the DLL is executed in the background, okay? So, well, that's pretty much from my side. These are the collections that we have created in case you want to take a look at the files that were involved in the research, and some of the some of the Jara rules that also we have created and are in our public GitHub. You can use them, you can modify them. The final goal of this talk was to show how you can use this kind of information into the platform to create some live run rules, to create some hunting queries, and identify similar behaviors that we observed during this specific investigation and get your threat hunting operations through the platform. So, well, that's all from my side. I think I'm good if somebody has some question.
Hey, sorry. Going back to the diagrams you showed, the pie charts and the percentages of the malware families, what was the duration of that data? So was it like last year's, or you're just taking...
The malware family is related to the link files, you mean?
Yes.
Okay.
It was like 32% had...
Yeah.
Those probably the wrong numbers, but yes.
The timeline of that we use for that specific is in the first one of the first slides. I mean, no problem, because I don't recall exactly when it started. Let me show you exactly the timeline, because the scope initially for the link files for us started. There is in 2020 to 2024. Okay, so this is the timeline of the link files that we introduced into the investigation, and the malware families were in some moment in that specific time frame. Okay, so no, it's okay. Thank you.
Just looking at the timeline too, I'm curious, is when you started to observe this pattern, is it all related to sort of Microsoft's blocking of documents, their Word documents or Excel documents that have the mark of the web, to disable macros at the same time? It seems like there was a shift. I think right in 2022, around there, Microsoft started to block macros from being executed with documents with the mark of the web. Is there any correlation, or is this just something new that they've adopted? Because I think of ISO files and link files is kind of unusual for a user to be interacting with.
That's a good point. To be honest, we had not some kind of correlation to verify if that's the reason or not. But what we have observed is, yeah, that definitely the LNK files, at least for the last month, we are seeing a lot of use, not only for APTs, but also for cybercrime groups, where they are using this kind of specific, some kind of artifact during the operation. But I'm not sure. I'm not sure if it is related for the macros of Microsoft Windows that they were disabling or not, to be honest.
Hi, Joselillo. In the beginning, we saw that these were coming from campaigns both in China and in North Korea as origins. And we also saw the different methods that they had to deploy the decoy, the PDF decoy. So have you seen any difference between the Korean and the Chinese campaigns in that sense? How they change the TTPs, or they kind of act the same?
Yeah, which is a reality, I would say, is that most of the threat actors that we observe are based in that specific area. I mean, we observe mainly the threat actors based in China, threat actors based in India, that are using this specific operation. But what I have not seen is Russian threat actor or something like that using this specific behavior, at least from my visibility during this specific investigation. And that's something interesting, at least for me. But probably because I would say that this is okay. It's not rock science. I mean, it's a link file that you are using to execute some PowerShell command. It's not like you are not developing a malware from scratch or something like that. For me, the Russian APT threat actors have more capabilities to do that. And this is easy to detect in the internal infrastructure and so on. So what I saw was that threat actors, not Russian threat actors, were the most using this specific behavior.